Hello, everyone. Welcome to MySec Lansing. My name is Brian Martinez. I'm the director here for this chapter. I'm excited to see some new faces here tonight. Excited to see mom and dad over here too. Not my mom and dad, of course, but our speaker's mom and dad. I think that's awesome. I wish my parents showed up to my talks, but that's all right. They'll watch the stream sometime. Anyway, so again, welcome all the new faces. Welcome everyone else who's been here before. I hope you enjoy this nice new location. I'd like to get this location again. If you've not been here before, you guys are going to hear this again, even though I gave it to you casually before. We're all about, no barrier to entry. We want new people here all the time. We're about making connections in the industry. We're about giving people the opportunity to speak and just learn new things. We have several other locations. I'm going to give you the rundown of their talks, which are happening this week and next. And you can either check out the YouTube stream for those, or maybe you can even show up and network with folks there and learn a thing or two. So of course, we're here in Lansing. I'll introduce our speaker shortly. Detroit is also happening right now. Unfortunately, they do not have a stream going on, so there will not be a recording of that on YouTube unless there's some miracle that happens that's happening in the back channels. But Detroit's happening tonight. We have a brand new director there. That's Xavier Infinite Johnson. He also runs DC 313, if you guys have been to that. DC 313 is more of a red team thing, and MySec is certainly more blue team than red team. But let's see what else we got here. Tomorrow night we have Grand Rapids at the Grand Rapids Community College. They have a talk called Sigma, LOL, Boss, GTFO, Bins, and Me by Reaper. That's from 6 p.m. to 8 p.m., again, at the Grand Rapids Community College Applied Technology Center Maker Lab. Also tomorrow night, we have Southfield giving a talk, a panel discussion, called What You Wish You Knew Before Entering InfoSec. And that sounds pretty promising. There's a few things I wish I knew before I entered InfoSec. So be sure to check out the streams for that. Next week, we've got Jackson on Tuesday from 7 p.m. to 8 p.m. Kyle here, our gracious videographer, will be hosting that, and he will be having a discussion of current events, Iran, and cyber scary thoughts. That sounds very intriguing. Hopefully it doesn't get too political, but maybe it will. So in addition to our talks this week and next, we do have the call for proposals for papers for Converge Detroit. Converge Detroit will be happening this year on May 14th and 15th. So if you're interested in presenting, please go check out the site. There's also an opportunity to create a workshop, a 4-hour workshop. If you guys have professional certifications, you can really gain some CPEs, either creating a presentation or a workshop. A lot of those organizations allow you to double or even triple up your CPEs for what it is that you've done, which is pretty nice. So again, check out, was it convergeconference.org for the CFP, or is it .com? .org, okay. For the CFP, or if you're interested, you want to bounce an idea off me or Kyle, let us know. We'll be happy to chat to you guys about that too. Let me think what else. Next month we do have our Ann Arbor chapter starting. That will be hosted by Kent Pycat Gruber. I do not know the location yet. That's still a work in progress, but we're excited to have Ann Arbor in the mix. And in a more regular meetup there too. With that said, I'd like to introduce our speaker for tonight. He is, so I work at Michigan State University as a security analyst. I got to know him as our student intern, one of our student interns. He gave this presentation, or a version of this presentation, I should say, what was it, 2 months ago, 3 months ago?
End of summer, yeah.
Okay, several months ago. And I found it very intriguing. I asked, hey, would you like to make a longer version of this? Because I think people could really learn something from this. He agreed, and he's been plugging away at it over his winter break. And I'm thankful that he's here. And this is Sam Gendleman. And I'm going to turn off my mic and allow him to step in here. Thank you.
Hi, I'm Sam. And as you can see from the name on the presentation, I also can be reached here at my email, gendlemansa@samuelarongendleman.com, if you have any questions or conversations you'd like to have. So a look into networking labs. and a guide on how to build your own. So I'm going to start off here that a little bit about me. So I'm currently a senior computer science student at Michigan State. I have interned at Michigan State University, as Brian has said. I've also worked 2 years in software development before I was here, and I like ice cream. Some fun fact about myself. Now, you didn't come here to learn about me today. We're here to talk about what a networking lab is. Now, to some people, it is a daunting task to create a networking lab, and I'm here to show you it really isn't when you put it down to a couple of steps. So I would define a networking lab as seen on the slide. I would define it as an environment scaled down that uses physical and virtual components to mimic how a real-life network works. A real network, but just scaled down in size. So when you create a lab, you're actually creating your own network. The same thing that you use to watch YouTube, go on Facebook and Twitter. Now, how can a security team or person utilize a lab? And that's a question. Does anyone have any ideas on how someone could utilize a lab? And there's no wrong answer. Training. That's a great one. You could, of course, use a lab to train new employees to new software, new hardware. Pretty self-explanatory. Anyone else?
You can use it as kind of like a dev environment for testing new tools that you heard about?
Dev environment for testing new tools. Now, that's probably the most common one that you'll hear today. Usually, whenever someone buys a new vendor, it could be scary putting in new software into your real network, just in case it could go down. So having a network lab actually helps with that because you can see or right with those changes. Now, why a lab? It's great for both professional and personal use. You can test, pen test. You can practice building new software, new hardware that you haven't used before. Put a sandbox in it. Have fun. And hopefully by the end of this presentation, you guys will know some of those reasons. Now, I'm going to go through a couple real-world examples here, home networks, and a lab of my own for MSU, actually. Now, as you can see here, this is someone's home lab. Now, a home lab this in-depth unless I had a lot of time on my hands. And you can see that they're pretty broad about explaining it. You can even see their computer and their database network. They got a whole bunch of stuff going on. Now, this is a snippet. I'm going to show you a couple snippets from a diagram that actually I built. And something you'll notice about my diagram is there's no routers or fancy computer images or anything. I just use straight shapes. And I think that shows that you don't even need fancy diagram software to even make a lab diagram. You can just go off of what you have. In fact, my later example, I will show you that further. This is another example. VFW0, and then a couple of virtual computers at the end. So this is all virtual environment. Here's a real firewall. Nothing too different from the last, maybe a VLAN, routes. And this is a switch. And I wanted to show the differentiation just in case someone had a question about whether programming or designing a firewall or a switch in a diagram would be any different. And that's the lab altogether. Now, you may be asking yourself now that you've seen a diagram of the lab, how would I make one? Now, there are many questions you actually should ask yourself before you take on the building process. Size of lab. You're going to have 60 computers, you're going to have 50 computers, you're going to have 10 computers, you're going to have 2 VMs. That's the type of question you need to be asking yourself before you really jump in. What is the complexity of the network that you're trying to make? Are you going to have special HA pairs for your firewalls? Are you going to use VLAN tagging? That's the type of stuff you want to ask yourself before going in. just so you know what you're trying to build. And then the biggest question of all is, where are you physically going to keep the lab? Because I can guarantee you, if you buy like 20 server racks and then try fitting them under the bed, it is not a good idea. So I'm actually going to simplify the building process that I went through in 5 separate steps, or 4 separate steps. I say 5 because planning is technically 2 parts, but we'll cover that. Now, planning part 1. What are you trying to make? I know I just asked you what type of lab you're trying to make before, but this is some good reiteration. What are you trying to make? Are you trying to make a CTF lab? Are you making your lab at home? Did your employer ask you to build a lab? Some of these questions should be easy to answer. Now I'm going to talk to you a little bit about the difference between a professional lab and a personal lab before we move on. A professional lab might be used to test new hardware inside of your network infrastructure. As Ethan said, you can also use it to test new software and vendors into the network. You can also expose the vulnerabilities of your network without risking the production network at hand. You don't have to pen test your actual network if you have a copy of it laying around, right? Training employees, that was something. And as well as debugging. And this one isn't as clear to mind, but say if you have a problem with your network, say there's a loop somewhere, you can use labbing as a way to find these problems without hurting your actual network in the process. Now we're going to talk about personal. Personal labs are something of what hobbyists do. I showed you a home network beforehand. That guy obviously had a lot of time on his hands and made it a great network. You can not only mess with scammers on the phone, put your own sandbox in your lab, but you can also secure your home network. You can also train, which is something that actually I have done over the years, has made my own lab and trained in pen testing. But now that we got that covered, the difference between personal and professional, I want to talk about the technical. Do you want VMs? Unless you have laptops laying around using. What type of hardware do you plan on using, right, in your lab? I can tell you it's really hard to get licenses. Licenses for major companies' brands. If you want a Palo Alto firewall, it's going to cost you. Whereas if you can get yourself a nice maybe $100 firewall, or even what I like to use is a virtual firewall brand like pfSense. Completely free, easy to use, and hop in. Here are some of the I've used in the past. I've used VMware ESXi, which is a great host to put all of your VMs in. You just need a good place to store it. I suggest a desktop computer because it's an entire operating system that holds your VMs. Free firewall. Really nice to use, and it gives you all that you really need. I use Linux form of Linux or Unix. System at my bottom layer. I usually use that to test, which we'll be talking about. Metasploitable 2 VMs, and I know that Metasploitable 3 VMs are out, but those require extra configuration to use inside of your setup, even though it might be nicer to have. It just depends on how persistent you are and what you want at the bottom layer. But I like Metasploitable 2 VMs because they are ready to go right out the bottom. Now I'm going to talk to you about one of the most important parts of running a lab, and that is designing. And some people here might be asking themselves, well, I know what I want. I know that I have the parts. Why don't I just jump in and start building? Well, I would tell you to go do that and come back to me a day later and tell me what you did wrong. Because when you start building blindly, how the hell are you supposed to know what you're doing, right? When you come back from coffee break after working on your lab for about 3 hours and you realize you don't know where you put what and what goes where, that's when you're going to realize that you should have built the design instead. Diagrams are easy to make, and I'm actually going to a live process showing you how diagrams. You can also a lot of very nice information to have. Routes, interfaces number, VLANs. You not only get to see what's happening on the physical level when you look at your lab, but when you bring out your design, you're able to see what goes where, what goes to what subnet, VLANs. Now, there is a small warning I have for design, and it is to make sure that whatever you're putting in your design is relevant to the lab. So maybe don't put the exercises that you're going to run in your design. Leave your lab design as it is. Make sure it only describes the network at hand. So now I'm going to go over a live example of building a diagram. My first steps that I would start with is to start with the device itself. The name of the device and the type of the device should be pretty much good. If you want to be any more descriptive, that's on you. I also put the management IP because it's better to know what management port and IP you use, because when you come back down the line and you, say, years from now, realize that you need to change the firewall setting because it's wrong, well, this allows you to come back and say, okay, I know where the IP, what the IP is, and now I can change it. So here is our box, and notice I actually made this in MS Paint to show that you don't need any major software to design. There's also other major design softwares that are free. I believe Sketch.io is another one of them. Firewall 1 right here, pfSense. So you can see I named the firewall. pfSense is the type of firewall. Management IP 192.1.1. Pretty straightforward. Next, we're going to move on to present security zones. Now, I wrote, if any, to have security zones. If it's a switch, of course, it probably won't have security zones. Pretty much the zone name should suffice. And I also would advise using different shapes to represent different things. That's because when you come back to looking at your diagram, instead of looking all at the same shape over and over and over again, it's easier to tell what is what and separately. I wrote an untrust and trust zone. Pretty simple. I used ovals and then connected them with lines. I then define interfaces. Now, with interfaces, some people like to only put the IP of the interface down, and I would say that you probably want to also add the number interface, because when you come back to looking at your diagram and looking at the physical lab itself, you'll be able to tell which interface goes where and to what IP. For HA pairs, I also think that putting down your control and data link interfaces and IPs are important. And I know for some vendors, they might automatically assign IPs for the data link and control. But of course, it's different across the board for every vendor. So also, so you can see here I used two rectangle shapes to represent my two interface IPs, as well as the interface number. You can also put interface subnet. That's actually preferable as well. Putting the subnet down makes life also easy for when you're trying to connect some other device up to your current firewall here. Next, you want to add your routes. Of course, add the IP subnet of the pack. So this is a confusing sentence here. Basically, what I'm telling you is to make sure to add your routing subnets into the next hop to where they go to, including your default route. And when I show you the next slide, maybe that'll make a little bit more sense if you're still confused. So as you can see here, this top 10.0.4.0, that means anything that's going to 10.0.4.1, 10.0.4.2, 10.0.4.3, so forth. Anything going to 10.0.4. whatever is going to go. We're setting up a point-to-point routing here, some point-to-point routing here. Then you see on my default route 0.0.0.0. That means anything that does not describe what we've already described above with the routing rules, that will automatically go to 10.0.2.2. That's basically how we get packets out of our firewall here. Next, we finish up the device, adding any VLANs. Now, VLANs are very important to have in a lab because I feel that microsegmentation is something that is very common in networks today, and it is something that should be emulated in smaller networks as well if you want to get the real authenticity of it. But besides that, there are actually two different types of VLANs that we'll use in our diagram. There are routing VLANs and edge VLANs. And I am about to go through the difference right here. So a routing VLAN is something that, the short version of this is, the routing VLAN is in the middle of the network. It's not at any of the edges. And I will actually show you an example here, and then we'll go back to the diagram, some of the diagrams I showed you previously to kind of see if you can tell which one's a routing VLAN and edge VLAN and whatnot. But for routing VLANs, I use a naming format. I do the ABC format is what I call it. And A is the type of connection, DHCP, point-to-point. It doesn't matter what it is. Just put down the type of connection from each router or each device. Then I always do the source device. So that will be whatever the VLAN is coming from. And then the destination device. That is wherever this VLAN is sending out to. I also add a nice redundant VLAN number at the bottom. So for example, 10.0.3.1 will be under VLAN 3, and that's just so I know what packets are going under what VLANs. Edge VLANs. For edges, I name them a little bit differently. I call those edge trust VLANs. Now, the number at the end, the little hashtag at the end there, stands for the subnetted network behind the VLAN. Now, and I also add that VLAN number again, although a little bit redundant because you already have the VLAN number up in the trust blank, right? So you're going to see, I just do it just to make it easier to spot when you're looking through the graph. Say you're kind of sliding through looking for something. So if you look here, I have a nice little example here. I wrote routing VLAN P2P Cisco pfSense VLAN 2. What that means is there is a point-to-point connection coming from the Cisco firewall that you can't see, shown by the arrow, and it's headed towards my pfSense firewall into the network. And on the other side, you see Edge VLAN Trust 3, and you can see that I named Edge VLAN Trust 3 because on the interface 1, 10.0.1 is heading out of our pfSense into a laptop. Now, the reason why this is an edge here is going to the laptop, which is at one of the ends of our lab. It's kind of like a tree diagram. The nodes in the middle are considered routing. The nodes at the end are considered edges. Now that we've built our diagram, we can now go on to the building phase. And building phase doesn't need much explanation because you already know what to do. You're going to encounter problems. There's always problems to be encountered when you're building a lab. I mean, what is something that you do that doesn't go wrong, right? Even a little bit. Sure that as you go through and you do make changes, that you change your diagram as well. This is because your diagram isn't only going to be used by you if it's a professional network. You're going to have to share this network with your colleagues. Understand what you're doing. That's my rule of thumb. If you can show someone who has your diagram and explain it through, you've made a good. So make sure you do update your diagram and make sure it's clear. Testing is one of the most important steps. This is like the moment of truth, the drum roll at the end. It's because this will tell you if you've built your network completely. If you haven't built your network completely, then you'll know from testing. Your test should fail. Now, there's a couple of different tests that we could have for our lab, and I'm going to go through a couple of these right now. So the biggest thing you should be doing is you have your design of your lab. You know what devices should connect to what. And your entire lab should be able to talk to each other. If I send a packet from this end, it should get to this end. And if I try sending a request from this end, it should make it out this end. And everything in between. Having like a ping sweep there makes sure that all of your devices are all up. And if you ever are having trouble with your lab, you'll be able to just use your ping. Other types of tests include trace routes, of course. If you are trying to route a specific way using tagging or just routing in general, point-to-point or BGP or anything, you want to be sure that your routes are correct and you want your lab working as intended. So that's a great way to see what nodes are hitting and what nodes are not. Next, I would try doing some request tests. Do you have firewall rules? Are they working? That is what, that's how, say you have a HTTP blocked. You're going to try making web requests. Wanted by every, of course, blue team engineer. I think that having logs on your machine only provides huge benefits. You can see what's wrong, see what's coming through, and if you run CTF labs, you can see maybe what the participants were trying to use that were getting blocked. And you can for home networks as well. So now that we've talked about how to diagram a network, these diagrams should look a little bit more familiar to you. You can see now that I used Edge VLAN Trust here, Edge VLAN Trust 9 and 8. You can see that I put my see my routing table, my interfaces. On my switch, you can see the VLANs that I've used. You can see the routes for the switch as well. Like I said before, you don't need to just make use firewalls in your diagram. You can have security zones. This is an example. The interface VLAN 4 and the switch interface VLAN 7 here is also an example of VLAN tagging, as the switch interface VLAN 7 may go somewhere else compared to the switch interface VLAN 4. Now, does anyone have any questions?
So in the design phase, how you kind of laid it out was you had the firewall first and then you kind of designed outwards. Is that how you would want to build it as well? Or does the order not necessarily matter when you're building?
The order, I think, doesn't necessarily matter. I think if you are up to the World Wide Web, like your ISP, you want to start with the device at the topmost layer and work your way down. That makes it easier to kind of see your progress through the lab, whether you're half done, not done, or whatever. And it's helpful to see in building. Yeah. Any other questions?
So, sure. So me, a non-technical person who has never done this before, despite the fact that I've sat through your presentation.
Yeah.
So some of these things that you have in your virtual lab, right, like a Cisco router or whatever, is there like software that emulates that when you're setting this up, or how can you say this is a Cisco router? You know what I mean?
Are you saying virtually?
In a virtual lab, yeah.
In a virtual lab, yes. There's actually operating systems like OpenWRT, for example, is a operating system for a router that you can do all sorts of fun stuff with, including emulate in a virtual VM. So really, when it comes to VMs in your lab, the world is really like I don't know what to say, like your playground. You can kind of choose what you want. You can even have IoT devices in your lab as well.
That's cool.
Mm-hmm. So you can emulate a lot of different things.
What are some of the things, you said you've been doing training in your own lab environment. What are some of the things that you've learned in your time messing with this stuff?
Definitely. I have explored a lot with pen testing through it. If you want to do pen testing legally, which is, I think everyone, yeah, highly recommended that you do it legally and not illegally. I don't support illegal pen testing by any means, but
Nobody here does.
yeah, no one in the entire room is a criminal. So, I would say like you're able to mimic what it's like to be like, say I'm in the same room, I'm in a coffee shop or something, and I'm able to connect through someone's computer by just doing some reconnaissance and trying some basic attacks out. You can kind of emulate that type of environment, like being connected through a router, being connected peer to peer. You can, like I said, when it comes to like virtualization, the world is your oyster, and you can kind of do whatever you want and create whatever scenario you want. Another great thing about use is I run a sandbox in it, and having the sandbox is really cool if you're into running malware and stuff like that. You can get a lot of cool analysis out of it. You can also do, like, you can kind of make these database setups in your house too that connect to your lab, so you can manage like pies across your home with your lab. You can do a lot of cool stuff with it.
Sounds pretty cool.
Mm-hmm. Anyone else? Well, I'm gonna wrap up real fast. Oh, we have a question over there. I don't want to.
So I'm assuming you did not start out with the setup you described, or did you?
The setup?
The lab setup you described.
Yeah, actually, that was the lab I've ever made. So honestly, what happened was I expressed interest, and what they said, if you want to do this, you got to go, but you got to do this yourself. So they basically, and with a little help from, it became true. Really, it was a task at hand that I threw myself at, and that's why I want to encourage everyone here and maybe garbage parts and like do this type of stuff. So, like, honestly, anyone can.
Thank you.
Mm.
Physical device, like lab environments, right? Against Cisco firewalls and stuff like that.
Of course.
You talk about pfSense. Do you run pfSense on your ESXi server?
Yes.
How you typically set that up? Or?
Yeah, ESXi. So the wonderful thing about ESXi is like you can route things actually really well under ESXi. I don't know if anyone tried to do that under Oracle and was like, oh, well, there's no options. You have to kind of run it one way, host only or internal network adapter. But with ESXi, you can make like 18 VMs, and you could route them however you want. So you could actually have like 3 firewalls where one firewall connects to the next firewall and so forth, or like any order you want, or 3 separate firewalls all going out to the same wire. That's the coolest part about it. It's really flexible.
Is it possible then to run pfSense in like VirtualBox?
Yes.
Okay.
Yeah. You can do VirtualBox. You don't get as many options when it comes to where it connects and what it connects to, and it might be a little. I feel like ESXi for me, even though there's maybe a little bit more extra steps, you get a lot more complication, but you get more. You can kind of configure it more to your needs.
It's free too, isn't it?
Yeah, VMware ESXi,
Why not do it?
exactly, completely free. You can throw it on a VM and have it do VMs. You could have a VM that runs VMs. You could have, if you have a spare computer, throw it on your computer. It's easy as just putting it on a flash drive and booting it up. No more questions, right? All right. Well, thank you guys. I hopefully.
I do. So there's a question from the internet.
Oh, perfect.
How do you go about enjoying pen testing your own lab when you already know everything about it?
See, that's actually a great question, right? Because you set up your own challenges. How do you have fun? Honestly, when it comes to pen testing on my own lab, I do stuff that I don't know. Because if you do the stuff you already know, you're not going to have fun. Like if I throw a Metasploitable framework up in my lab and then I start pen testing it, you know, Metasploitable has like a million different exploits already on the VM. But it's like up to you to choose which exploits you want to learn, right? So you can use this as kind of like a practice ground for what maybe might be to come later on in your life. You know, learn different methods, different things, different tools. It's even though you do expect you have an expectation of what's going to happen, of course. But then again, it's all educational. All right. Well, thank you guys. Hopefully you can go out and build your own network now. I'm going to back to Brian here. Thank you guys.
Thank you. You're off? Yeah. Okay. Thank you, Sam, for that excellent presentation. I definitely learned a couple of new things here, even from last time. Thankfully, because I asked you those questions and you had an answer for me. So as I said at the top here, you know, we're a no barrier to entry group. We're always looking for new speakers. Presently, I'm kind of on the fence with someone speaking next month, so if anyone has any interest, let me know. Even at any point during the year, it doesn't have to be next month. It could be March, you know, it could be December. Kind of to Sam's point that he mentioned at the close of his talk here, I would definitely suggest you push yourself and challenge yourself, whether it's with the talk or learning new things. Everything that I've learned in IT and InfoSec, well, maybe not everything, I'd say maybe 80% of what I've learned in IT and InfoSec has all been self-taught. So some things can seem daunting. Just sit down and attack it, see what happens. And if you mess up, you know, hopefully someone's there to help you. If you want to learn things about InfoSec and you're looking for a mentor or anything like that, we do have our Slack instance, mysec.slack.com. If you join up there, actually I think you got to go mysec.herokuapp.com. But if you go to our site, you can get an invite that way. Active conversations every day. All kinds of questions, all kinds of opinions. It's just 660 people on our Slack instance and growing. Yeah, that's it. Thank you, everyone.